Find the volume of the solid indicated by cylindrical shells. F of x equals x squared plus 1, g of x equals x, between x equals 0 and x equals 1. And we are going to rotate, this time about the y-axis. So the solid that we get is a pretty interesting one. Circle on the top, and it's indented on its way down. Vertical line, and it comes in like a top. So what we have to do is draw a typical shell. And the two most important things whenever drawing a shell are to find the average radius and the height. So the average radius is just going to be from the distance from the axis of rotation, the y-axis, out to some point along the way. And again, the book does this thing with the rectangles, but we don't have to. This distance is just going to be x. The height, though, in this one is a little bit different. The height is not going to be x squared plus 1. It's going to be x squared plus 1 minus x. So the volume that we get, according to our shell's formula, is 2 pi x, which is the average radius, times the height, which is x squared, and putting them in descending order, minus x plus 1. And so we're going to integrate that from 0 to 1, and we should have a delta x, and we do. The width of this shell is delta x. So the real challenge of these things is always just to set up the integral and not really the integration itself. But let's carry through the calculation. From 0 to 1, we get x cubed minus x squared plus x dx. And when we do the integration, 2 pi x to the 4th over 4 minus x to the 3rd over 3 plus x to the 2nd over 2, that's a 3 there, evaluated between 0 and 1. So plugging away, we get 2 pi times 1/4 minus 1/3 plus 1/2. So I'm going to write that as 2/4 if you don't mind, just to speed up some calculations. So we get 1/4 plus 2/4 is 3/4. 3/4 minus 1/3, and you always end up with these fractions in these problems, which I guess is 9/12 minus 4/12 is 5/12. So 2 pi times 5 over 12, which I guess can be simplified to 5 pi over 6.